done this part. Work and energy we have understood, and we did some questions from that. Right, so let's check if you remember this or not, right? So let's do one question. From height at a certain height, kinetic energy is times its potential. The height from the surface, so this is from work energy theorem, right? Okay, this is from work energy theorem. So this, but let us first understand what is work energy theorem, right? So far, what we have understood about work done. What is work done? Akib,
Fs cos theta
Fs cos
goes
theta.
into
Absolutely.
displacement.
Yeah. So whenever somebody asks you that what is work done, so we remember that it is by applying some force, we are moving some object with some distance, right? And that
Yes, sir.
is called the work done, right? So we write it as yeah. So work done is simply F dot ds or right. So this is work done. So uh, okay. So whenever we talk about work, we talk about force. What is the force applied and what is the displacement? So these are the two things that we talk about. Right. So work done is, as said, F is cos theta. But we have approved this theorem, right? And I will directly write, right? I will not derive this thing because derivation we have done. In the C base C portion, we have done this part, so we will not derive, right? So what does the work energy theorem says? It says that the total work done would be change in kinetic energy. Right, so this is what work energy theorem states. So total work done would be change in kinetic energy. So work done is delta K, where delta K is K final minus K initial, and where K final is half mv final square minus half mv initial square, right? So now,
Yes, sir.
whenever you see, right, whenever they want you to calculate the work done, so you will look at the force which is applied. But let's say if the velocities are given, right? If the velocities are given, then from this relation, you can calculate the work done. So this is the relation that relates the work with the kinetic energy. Okay, so this is what we call the work. And yeah, and now let us do some question from this right? Okay, so this question is from not from the work energy theorem, but the conservation of energy. So let us do this question, and then we'll get back to the work energy problems, right? This was the conservation. So let us this is this thing uses conservation of energy, right? So this thing we have already understood. So we'll directly do the question. So a particle is released from height s from the surface of the earth. So this is some particle and it has been released, right? This height is s, right? So
Yes, sir.
in here, what is the only force that is acting?
Gravitational force.
Yeah, gravitational force. And what is the energy? Only energy that is there.
Kinetic energy, sir.
It is at rest. So will there be any kinetic energy?
At rest, there won't be any kinetic energy.
Yeah. So only one energy would be there, right?
Potential energy.
Potential energy, right? Potential energy. So at this place, only potential energy. At this place, only kinetic energy, right? And
Yes, sir.
let's say at this place. So in this question, they are saying that at a certain height, right? At a certain height, let's say this height is x. So at certain height, the uh, the height from the surface of the earth and the speed of the particle that is respectively, right? At a certain height, its kinetic energy is three times its potential energy, right? So the total energy in here would be some potential energy, right? Let's say this is 1 plus kinetic energy 1, right? Is this clear?
Yes, sir.
So in here, the total energy is only the potential energy, right? So at, let's say this is one position, this is second position. So at 1, the total energy is what? So energy is only, let me write it as PE plus KE, but this part is 0, so only P. So how much is the potential energy at this point? How much is the potential
PE
energy?
0,
Yeah,
1. No, no,
at
no.
this point,
It will be
this is
0.
at potential energy is 0. What is potential energy?
MGH.
mgh. So this is the ground, right?
Yes, sir.
And the object is released from here. So at a certain height, s. So what would be the potential energy here?
0.
That would be mgs.
MGS?
Why potential
Okay.
energy? Because it is at a certain height, right?
Yes, sir.
So potential energy would be mgs, right? So total energy is mgs. Okay, now at second point, the total energy is what? Potential energy 1 plus kinetic energy 1. And it is given, right? It is given that at a certain height, its kinetic energy is three times its potential energy, right? So its kinetic energy at this point, its kinetic energy, let's say 1, is three times the potential energy 1. Clear? This is given.
Yes, sir.
So what we can write in here, we can write this as PE1 plus 3PE1. So this would be 4PE1. And you tell me, what is potential energy at this point? What is
Total
it?
energy minus kinetic energy.
No, forget about that. So this is at a certain height, right?
Yes, sir. So
Height
S
is
minus
x.
X, S minus X. So mg S into X. X minus S.
Okay, let's say you have this ground and this is at certain h height. So what is the potential energy at this point?
mgh.
mgh. So we have this point. We have this point, right? And this is the ground. So this is distance is x. So what would be the potential energy?
mgx.
mgx only, right? So this would be mgx because potential energy one is only mgx. Clear?
Yes, sir.
Now, do we know this energy? Do we know this thing? From energy conservation, we know, right?
Yes, sir.
Whatever the total energy is at this point, that would be equal to here, that would be equal to here. So let us calculate that, right? So this E is mgf, right? And this is 4 mgx. So mg cancel, so we will get x as s by 4, right?
Yes,
Clear?
sir.
So what are the options which is matching? The height from the surface of the earth. So the height from the surface of the earth is s by 4. All these are matching, right? Now we have to find out the kinetic energy, right? We have to
Yes,
find
sir.
out the velocity. We have to find out the speed of the particle at that instant. So we have to find out that with which velocity it is dropping. At this point, we have to find out the velocity. So what we can use, which relation can use?
Um, which energy, which relation can we use? No, there is no graphical method, no variable force.
Yeah, just look at just look at the definition. What is kinetic energy?
Definition of kinetic
What is
energy.
the definition? Yeah,
Hmm. Half mv square it is. I only know that much. I don't know definition.
yeah, yeah. Yeah, so the energy by virtue of motion. Yeah, so that is correct. Kinetic energy is half mv square. So if you are given the kinetic energy, can you calculate the velocity?
Yes, sir.
Yeah, so okay, so we'll use that relation. So the aim is to calculate the kinetic energy, right? And it is given. What is given? That kinetic energy is 3 times the potential energy. Correct.
Yes, sir.
So we know that at that point, kinetic energy would be half mv square. Clear?
Yes, sir.
And potential energy is how much? mgx.
mgx.
M cancels. X we have just calculated, right?
Yes, sir.
So this would be 3 into 2, and g and x is s by 4. So this two will cancel, and we
Sir,
will
but
get
why two?
this. Oh, I have taken this 2 in this side, right?
Okay. Yes, sir.
So this 2 goes over there, right? So this is 3gs by 2. So v would be how much? That would be 3 by 2 gs, right? So what did we use? We just used the energy conservation, right? Energy. So we saw that what is the total energy at this point? What is the total energy at this point? What is the total energy at this point? Right. So,
Yes, sir.
and this relation was also given that at a certain height, the potential energy was the kinetic energy was three times. This relation was given. So we just used that relation, and then we got the position, and then after getting the position, we just calculated the velocity. So this was the idea. Is this question clear?
Yes, sir. Clear.
Okay, please note it down, and then we'll do some question from work energy theory.
Yes, sir.
So D option would be correct, right? Both these are looking like same, but this option.
Yes, sir. I was having doubt, like if this type of MCQs came, like where two answers are
Yeah.
same, then which one should we take?
No, no. So both answer are different, right? Yeah, this is tricky because this route is on only on this 3GS, right? And this route is so all over. This route is
Yes, sir.
as a whole. So this one is the correct one, right? We got route as a whole.
Okay, sir.
Yeah, whenever I have noted it down, please go ahead.
Yes, sir.
Yeah, whenever you have noted it down, please enter.
Yes, sir.
Yes. Okay, noted.
Sorry, sir.
Noted.
No, sir. Little what I got wrong, so I'm doing again.
Oh yeah, yeah, yeah.
Like I'm trying with myself first, so that I can find where I can't, uh, like understand.
Oh yeah, yeah, yeah. Okay.
Yes, sir.
Yeah, and if you have a doubt, please ask. Okay.
Yes, sir.
And whenever you have completed, please.
Done, sir.
Let us. So now let us do some question from work energy, right? And this theorem is very, very important, right? And how do we derive this theorem? You remember, right?
Yes, sir.
Okay, let us find some question from work energy. This is from power. This is yeah. This question is from vertical circle. This question is from work energy. But this is a graphical. Oh, Rishita is joining. Okay, so all the question they are, yeah, this one question is from work.
So,
Yes, good evening, yes, yeah, this
so
question is,
I try
yes,
to like join a lot of times. I tried to join a lot of times, but I couldn't.
yeah, no worries, yeah, 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 maybe you were facing some issues, yes, no worries, don't worry about that. Yeah, so we just understood about the work energy, right? So we have just done this part. So we have just started from here and we are trying to find out one question, right? So let's say that let me generate or let me produce one question. So let's say that a particle or an object velocity or an object which is at rest was applied by some external force and its velocity becomes, let's say, 4 meter per second square. The mass of the object is 10 kg. Find the work done by the force. So you guys can see that, right? You guys can see that there's this external force, but the value of external force is not given. Only the velocities are given, right? So whenever the velocities are given, you guys don't think about this to try to find out this force. You can use the work energy theorem directly, right? So from work energy theorem, what we can write? We can write that we can write that work done would be simply changing kinetic energy. So this is half kv final square minus m, half m v initial square. Right. We know that v final is 4 per second square. So acceleration, not velocity, right? So this is meter per second. V initial is 0, right? So mass is also given, which is 10 kg. So work done would be how much? That would be half. M we can take common, so this is V final square minus V initial square. So half mass is 10 kg and this is 4 into 4 minus 0 square. So this is 5. So 5 into 16, which is 80 joules. So this would be the work done. Right, you guys please note it down. And Rishita, we have just wrote this work energy theorem and we are trying to do some question. So you guys please
Yes, sir.
note down. Yeah, you guys please note down this part. Then we'll quickly do some problems, difficult problems, and then I will talk about this vertical circle again. Right. So this part I did in the CBC class, but that I will describe it again.
Yes, sir.
Yeah, whenever you guys have noted it down, please. Whenever you guys have completed.
Done, sir.
Then Rishida, what about you? Done.
Done, sir.
Okay, so always remember this that you can calculate the work done by force or by change in kinetic energy. Right. So this is F dot S, or if we are talking about small work done, so that would be F dot ds. Right. So always remember this. Okay. And yeah, let us do some question about. This is vertical circle. This is graph. This is vertical circle. Vertical circle. Yeah, this one. This one is different. So always remember that we can calculate the work done by force or change in kinetic energy. These are the only methods from which we can calculate the work. So consider a drop of ray water having mass 1 gram falling from a height of 1 kilometer. It hits the ground with a speed of 50 meter per second, right? Taking g constant with a value of 10 meter per second square. The work done by the gravitational force, right? Work done by the
Yes, sir.
gravitational force would be how much? That would be the potential energy, right?
Yes, sir.
So we have to find out the work done by the gravitational force. So we know that how can we calculate the work done? How can we calculate the work done? We can calculate the work done by force, or we can calculate the work done by kinetic energy. Right? These are the only two methods that we have. So if we are given the force, we calculate the work done by force. If we are given the kinetic energy, then we calculate the work done by the kinetic energy, change in kinetic energy, right? Okay, so the work done by the gravitational force, right? So we have to find out what is Fg, right? What is Fg? Fg is what, guys? Fg is what?
1.
Fg is 1. Fg is mg, right? Right?
Okay, sir.
Force due to gravity, that is mg, right? And then we have to calculate the uh, height. What is the height, right? So h is 1 kilometer, right? So we have
Yes, sir.
to, yeah, so we have to find out the work done by the gravitational force. So that would be F dot S cos theta, right? So F is mg, S is 1 kilometer, right? And we have to change
Yes, sir.
it in meters, right? So we have to change this in meters, so that is 1000. And theta is what? So force is downwards, and displacement is again downwards, right? So what would be the theta angle? What would be
90.
theta? So force is downwards, right? And the body is moving in the downward direction. So what would be the
0.
theta? Theta is right. So theta is 0, which means that cos 0 is 1. So this would be mg h, right? So mg, m is how much? 1 gram. G is 10, and this is 1 gram is 1 by 1000 kg, right? This is 1000, so that would be 10 joules. Clear?
Yes, sir.
Yeah. This would be the work done. So that would be 10 joules. So there are two options. One is this, the other one. And now we have to find out the resistive force of the air, right? We have to find out the resistive force. So resistive force by the air. And we have to find out the magnitude of that. So this rain is falling, right? This rain is falling, so there are two forces which are involved. One is the gravitational force, and the other force is the air resistance. So air resistance is moving in this direction, right, guys?
Yes, sir.
So the total work done, right, to have this drop to fall down. So the total work done, that would be the work done due to gravitational force and the work done due to this resistance, right? Air resistance. Clear?
Yes, sir.
And total work done in terms of, because we can also calculate the force, but we don't know the resistive force, right? This force we don't. So we have to calculate this work done with kinetic energy because the rain is falling from rest, right? And it has a final velocity. So these two things we right. So we have a V initial, which is 0 meter per second, and we have a V final, which is 10 meter per second. Right? So we know that from work energy theorem that would be change in kinetic energy. Right? So this mg we have calculated that is 10 plus this is air, and this would be how much? Half k final square, half mv final, right? So m v final square minus half m v initial, right? So
Yes, sir.
this is 10 plus work done due to resistive force, and this is half. Mass is 1 gram, which is 1/1000, and then V final is 10 meter per second, right? So this is 10 into 10. So two tens are gone. This is 1/20, which is how much? So 1/2 into 10. So let's multiply by 10 and divide by 10. So this is 5 by 100. So this is 0.05. So this is the value in air. So what would be W air? W air would be 0.05 minus 10. Right. So this is how much? This is 0.95 joules. So this is work done by the resistive force. Clear, guys?
Yes, sir.
Clear. So now work done due to resistive force would be how much? That would be F into R, right? F into H, whatever the distance that it has moved.
Sir, shouldn't it be 9.95?
9 point, oh yeah, that would be 9 point. Yes, correct. Yes, so 9 point, because this is 10. So minus 9.9. Yes, yes, correct. So this would be minus 9.9. Okay, so this is the work done, and now we have to calculate the force. So we know that work done is force into displacement. So we know that force would be how much? This is force into displacement, and this is the 9.9. So now we can calculate this F air. So F air would be how much? That would be minus 9.95 divided by 1 kilometer, right? Which is how much? Which is 9.95 divided by this 1000. So this would be, oh, so this is how much? We're not getting this answer right. Okay. Yeah, so what did we do wrong in that? So half MP final square, right? So WA we can calculate. And oh, so this is 50 meter per second, right? Not 10 meters. So I have taken this final velocity as 10 meter per second. So this is 50, right? Not why didn't you guys correct it here? This is 50 into 50. So two zeros are gone, right? And then this is 25. So again, let's multiply by 10 and divide by 10.
Sir,
Yes,
shouldn't we do 50 minus 10? Final minus initial.
Yeah, so initially is 0, right? The raindrop are falling from a height 1 kilometer. So they are falling, let's say this is 1 kilometer. So they are falling from here. They don't have any initial velocity.
Okay, sir.
And then before reaching the ground, their velocity is 50. So V final is not 10, it is 50 meter per second. Right? So this would be how much? This is 5. So 5 into 5 into 5. So that is 125 divided by 10. So this is how much? This is 12.5. So then this would be how much? So 12.5 minus 10. So this would be how much? Okay. Yeah. So what are we missing? Yes. 25, 125 divided by 12.5. So 12.5 minus 10.
12.45.
12 point, not 12 points. This is 125, right? This is my there. Okay. So consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. It hits the ground at a speed of 50 meter per second. Take G constant with a value of 10 meter per second square. The work done by the gravitational force and the resistive force of the air. Oh, so they are only, yeah, they are only telling us the work done by the resistive force. Right, so they are only telling us to calculate the work done by the resistive force. So that we have to calculate, right? We have to calculate the work done by the resistive force, not the resistive force they want us to calculate. So we have to find out this work done, right? So this should be, yeah, 5 and 125, 12.5 minus 10, so this is 2.5 here. Yes, the mg m is 1 gram times 10 and so this is 10, so that is correct. And then work done by the resistive force. There are two forces which are involved, right? One is this gravitational force, so that is 10 joule, and yeah, 110. Okay, so there is something wrong in this question. Let me start from like whenever we are stuck, let us start from beginning. Yeah. So again, what are the given things which are given? So let us first write that. Mass is given, which is 1 gram, which is 1 into 10 to the power minus 3 kg. So mass is given, and height is given, which is 1 kilometer, right? and which is 1000 meters, right? And then okay, so kilometer, it hits the ground with a speed of 50 meters. So V initial, that is 0. V final is 50 meter per second. And G is 10 meter per second square, right? So first we have to find out the work done by the gravitational force. So work done by the gravitational force would be the force due to gravity, and then the displacement, and then the cos of theta, right? So let's say if you have a force, right? If you have a force and you move this object in this direction, right? So you are moving, okay. So let us write in the I and J notation, right? So that would be very easy. So let us write that F and dot S. So F is how much? F is mg, and this is minus of g hat, right? Dot this S is how much? This S is also how much? So if we
1000 meter.
yeah, this S is 1000 meter, right? And the separation is so the displacement would be how much? Displacement is final position minus initial position. So final position is 0j, right? And initial position is how much? Minus of or this is minus how much? Right. So this object is falling from here. So y displacement would be how much? So this place is position is R1 is 1000 J hat, right? This position is how much? R final is 0 J hat. So if we calculate the displacement, that would be how much? 0 minus 1000 J hat. So this is minus 1000 J hat. So this is minus 1000 J hat. So yes, that would be plus mg and this 1000. That is correct. 1 gram is 1 by 1000. G is 10. This is 1000. So this is 10 joules. So this is correct. Only this option is correct, right? So this one is correct, but this second part, we should get minus 8.75. That is the only thing which is troubling, right? So second part is that from work energy theorem, total work done, that would be equal to the change in kinetic energy. So change in kinetic energy is how much? This is 10 plus W air. This is half K final M V final square. So W air is how much? Half. M is 1 by 1000 kg. V final is 50 into 50. And then what do we have? Right. So, okay, so this is minus 10. So this cancels these two. This is 25 by 20 minus 10. So this is how much? 25 by 2 is 1.25. Or right? So This is 1.25 divided by 10. So this is 0.125 minus 10. This would be how much? 10 and 1 to 5. This is 5. This is 9 minus 2, 7. Then this is 9 minus 1, 8. And this is 9. Okay, so we have to join another two, right? Please join the other. Yeah, so let me. Okay, so I'm doing a very stupid calculation mistake. Can you guys find that out? The earlier result was also the correct, but can you guys find out this stupid mistake? Yes.
Yes, sir. Finding.
So this is the mistake in here. Division, right? So this is 1.25 minus 10. So then we'll get minus 8 point whatever 5, and then yeah, so this is 927. So yes, this was the calculation mistake, right? So 25 by 20, that would be 1.25, not the other way around. So yeah, this was the error. So this we already got, right? This we already got. So this was Fs cos theta. So this was mg and h. So this was because theta was 0 degree. This was 1 by 1000, 10 and 1000. This was 10 joules. Right. So yes, I have confused you guys, right? Did you guys understand this part? So there was this calculation mistake in there. We can calculate the work done by force, or we can calculate the work done by changing kinetic energy. So these are the two things that we have to remember. Okay.
Yes, sir.
Yeah, please note it down. Due to one calculation mistake, we were moving here and there. Please note it down, guys, and then we will talk about another question. And whenever you guys want me to scroll down, please check.
Yes, sir.
Yeah, whenever you guys have talked. So remember in this question, they are telling us to calculate the work done by the resistive force, not the resistive force, right? Yes, noted, guys.
No, sir, the last part is remaining.
Okay.
Done, sir.
Done. Rishita, what about you? Noted? Yes, Rishita. Okay, so now let us find another question about this. Right. So let us find another question. Yes. The question, so let us do this. So remember, how can we calculate work done by change in kinetic energy or by the force? So both the forms are applicable, right? So an object of mass 500 gram initially at rest upon variable force, the velocity of the object at x equals to 8 and x equals to 12 would be the respective values of near. So this is the graph of force and x. So what can we calculate? In the force and x graph, what can we calculate?
X. Should I calculate X?
No, no, no. I'm saying that in force and distance graph, what can you guys calculate from that graph?
Area.
Yeah, area would give you what?
Area of work done.
So area of the region or area of the graph, that would give you the work, right?
Yeah.
Yeah,
Yes, sir.
so we can calculate from the graph, we can calculate the work done, right? And it is starting from rest. So we know that V initial is 0, right? So the idea in this question is that we have to we have to relate work done from force to work done from kinetic energy. That is the idea. So first we will calculate the work done from force and then equate it for the work done from kinetic energy. This is the idea of this question. Now, you guys tell me that the velocities of the object a point x equals to 8. So this is at this point, right? At this point, they want us to calculate the velocity. So what we can do, we can calculate this area up to here, and what it will give us? What it will
Sorry,
give us?
sir.
So if we calculate the area from 0 to 8, what it will give us?
The area under the two squares.
Yeah, the two rectangles. So this will give the
Yeah,
work done
rectangle
from,
and square.
yeah, the work done from 0 to 8 meter. Clear?
Yes, sir.
So that would be area from 0 to 8 meters. So that would be how much? That would be two rectangles as Akib is saying. So two rectangles are, let's say A, B, C, D, E, and F. So area of A, B, C, D plus area of B, not B, but whatever its point is, let's say M. M, E, F, C. So area of ABCD is length into breadth. Length is this thing, right? So what is the length in here? Whatever you say, if this is breadth, this would be length. If this is breadth, this is the length.
20?
So what is from here to 20, right? That is 20 into this length. That
5.
is 5. Good. And then from MEFC. So this
5.
is
2. No,
from
no.
here
3.
to here. That is, yeah, 3 into 10.
10.
So this is 100 plus 30, so 130. This is the work done from force. Clear?
Yes, sir.
Now we know that this work done would be equal to change in kinetic energy. So whatever at this point is the kinetic energy, whatever is the kinetic energy at this point, right? So change in kinetic energy would be half m v final. So they have also given the mass, right? So v final we have to find out minus half m v initial square. This is 0, right? Because v initial is 0. So then this 130, that would be equal to half. Mass is 500 grams. And please be careful with the calculation, because just now you guys have seen that we can do some calculation.
Yes, sir.
And V final we have to find out, right? So we have to find out this V final. So this would be how much? 130 into 4 divided by, yeah, so this is the V final square, right?
Yes, sir.
So then what is this root? So this would be 4 into 130. So what is this? 520. So what is the root of 520? Let me use the calculator. So what is the root of 520? That is 22.8, right? So this would be 22.8 meter per second, roughly. So this would be this much. Is this clear, guys?
Yes, sir.
And now we have to find out the, so now we have to find out also the velocity at velocity at this 12 meter, right? So what we will do? We will calculate the whole area. We will calculate the whole area and then equate it with half mv square, right, guys?
Yes, sir.
Okay, so this would be, did we do this? Yeah, let me check this thing correctly. So 5, 0 to 20, this is 5, this is 3, this is 10. So yeah, 30 and then 100, 130, and this is half m and v final square. So this is 520. So 22.8 meter per second. Now let us try to calculate the area of whatever this thing. So work done from 0 to 12. That would be how much? We can also, what we can do is that we can calculate from here also, from 8 to 12. What we'll
Sir,
do
wouldn't
from,
it be easy to do from 8 to 12?
yeah, 8 to 12 would be easy, right? Because
Yes, sir.
we already know this velocity, right?
Yes, sir.
So we can calculate from 0 to 12 or we can calculate from 8 to 12. That is totally dependent upon us. So, or we can, yeah, so we know this area already. So we can go for 0 to 12 also, right? Whatever is easy for you guys. So for 0 to 12, that would be 0 to 8 plus 8 to 12, right? This we already know, that is 130 plus 8 to 12 is how much? 8 to 12 is this part, right? This part is how much? So this part is
Minus 50?
minus 50.
Yeah,
Yeah, so
because
this
2
part
into
is,
minus 25.
yeah, so this part is 20, minus 20, this part is minus 25, right? So from here to here, this is minus 20, this is minus 20, and from here to here, this is 2, right? So this would be minus 40, right? Clear, guys? Is
So,
this
sir, what
a
about the down part?
down part is a triangle, right?
So, we want a triangle?
Yeah, so we'll also calculate this triangle, right? So this triangle is
Okay.
how much? This height is 20 to
5
25, so this is 5, and that is minus, right? And then we also have how much is the, this is 2.
to
So this is minus 10, right? So minus 10 and plus how much? So this is 10 to 12, so this is 2. And then this height is 10. So this is 20, right? So this would be how much? 130 minus 50, right? Plus 20 is plus how much is this? Minus 50 plus 20 is 30, minus 30, right? So minus 30. So this would be how much? This would be 100. So from 0 to 12, this is 100. Now we know that from 0 to 12, from force, we have got this 100 joule. And if we compare with the kinetic energy, so that would be half mv final square minus half mv initial square. This part is again 0, right? If we would have used from 8 to 12, then it would have been whatever the velocity was at this point, and that we have already calculated, so that would have been 520. V final square would be 520, right, guys? But we are not using that part, so yeah, we'll use this. So this work done is 100 and half m is 500 grams, which is this much kg, and v final squares. This is joules. This is 2. So v final square is 100 into 2. Now this is so this is root of 100 into 4, which is 10 into 4, which is 40 meter per second. So these would be the so, so 20 meter per second. So these would be the velocities at these points. Is this clear, guys? So we have used the idea of force and the idea of kinetic energy. Both these things applied together. Is this
Sir, maybe it is wrong.
yeah? Yes.
Area of triangle is half into base into height, right?
Oh yeah, that one. Oh yes,
So it will be -5.
yes. So it will only be minus. Yeah. So this is yes, correct. So this would be minus 5. So this is minus 5. So minus 45. So this is minus 25. This is minus. This is how much? 105. Okay. Then we didn't get simple answer. So 105. Yeah. So then 105, 105. So this would be 2 root 105. So how much is root 105? Yes, correct. Now guys have become intelligent. So of 105 is 10.24 into, so this is 20.5, roughly 20.5. So is this correct now?
Sir, what is V final?
V final is the velocity at this point. Velocity at 12 meters.
Yes, sir.
Yeah, so we have calculated the velocity at 8 meter and we have calculated the velocity at 12 meters. So this is what we are finding, right? We are applying
Okay, sir.
the definition of work done from force, and then we are applying the work done from change in kinetic energy. So these are two things we are applying. Okay.
Yes,
Yes,
sir.
is this clear, everyone?
Yes, sir.
Okay, you guys, please note it down, and then we'll talk about the other question. Yes, you guys, please note it down. Yeah, whenever you guys want me to scroll down, please. So did you understand this part, right? Because we are going from 0 to 8 meters, right? So
Yes, sir.
initially the object was at 0 meter and then it reached this 8 meter. So the speed in here was 0. In here, whatever the speed is, let's say that is v. So we want to calculate this v. And what do we know that from work energy theorem that would be minus mv final square minus mv initial square. This is 0, so only this much we get. And this thing we are calculating from graph. So that is the only thing that we are.
Yes, sir.
Yes, whenever you guys want me to scroll down, please. Yes, noted, guys.
Done, sir.
Done. Okay, this part also done.
No,
Yeah, please. Talk. Yeah, whenever you have noted, Rishita, please. Yes, done, guys.
Yes, sir.
Rakib, you have already. Rishita, what about you? Yes, Rishita, noted.
Yes, sir.
Okay, yeah. So we'll stop it here, right? And in the next class, we'll talk about vertical circle. So that thing we have already done. But in the next class, yeah, we will understand about that you have a string, right? And this mass is attached with this string, and you are moving this string in a circular direction. So then we have to find out the speed with which we have to throw that it completes the full circle, right? The minimum speed that we have to provide. So these are things we will have to do next class. Okay, so yeah, see you guys after an hour and yeah, Allah Hafiz guys, Allah Hafiz.
Thank
Thank
you.
you, sir.
Assalamu
Bye, sir.
alaikum.
Walaikum Salam, Allah Hafiz. Yes, hello Rifa, Assalamu alaikum.
Uh, hello, Alaikum.
Yes. Can you hear me?
Yes.
Okay, so I guess we have completed. Yeah, only few questions were remaining, right? So did you try the other ones? Which question? 13th one we did. So
Yeah. Yeah, I tried.
14th and 15th one. Do you have any doubt in 14th and 15th one?
No.
No, okay, good. So yeah, then let us start the new chapter, right? So then this application of geometry is done. So we can start this chapter. Yeah, so 14th and 15th, you don't have any doubt in the question. Then we can start. Okay, so triangles, right? So first we will talk about before we do that, right? Before we do that, yeah, do you remember two properties of the triangle? But before we do that, let us talk about the parallel lines. These are the preliminaries that we require. Right, so parallel lines. So if we have two parallel lines and then this transversal, then there are corresponding angles, and then there are alternate interior angles, and there are the angles on the same side. And of course, you have this vertically opposite angle and so on, right? So all these are equal, right? They are equal, they are equal, they are equal. Only this one, these ones are supplementary, right? So if I talk about these two angles, so let's say this one and this one. So they are alternate interior angles, right? And this one and this one. So they are also alternate interior angles. So these are the second kind, right? And then we have these angles. So this one and this one. So they are what kind of angles? Yeah, whenever you have parallel line and these angles, they are what kind of angles?
Which one? The white one.
This one, this one. Yes.
Corresponding one.
Yeah, these are absolutely correct. So these are corresponding angles, right? So yes, correct. And these angles would be equal. And then if I ask you that what are these angles? So they are interior angle on the same side of transversal. So these would be subdivision.
Can we call them as alternative interior?
Yes.
That is also called as alternative interior angles.
Yeah. So alternate interior angle are these ones we already talked about, right? These ones are alternate interior angles. Let's say these ones. This one and this one. These are the alternate interior angles, right? Because 1, 2, 3, 4. 4 are interior angles. So whenever we have these parallel lines and then this transversal, so we have 1, 2, 3, 4. 4 interior angles and then we have 1, 2, 3 and 4. 4 exterior angles, right? So these ones, 1 and 3, they are alternate interior angle. Then these 2 and 4, they are alternate interior angle. These 4 and 1s, they are interior angle in the same side of transversal. These are interior angle in the same sides of transversal. This one and this one. So these are corresponding angles. This one and this one corresponding angles. This one and this one corresponding this one and this one. So these are the specific angles in parallel lines. So do you recall all these angles? Yes. Is it clear, Rifa?
Yeah.
Okay, so we will remember this thing. And there is another property that we will use. That is that if you have two parallel lines, right? And then you have two triangles. Let's say you have two triangles. So let's say this one and this one. Okay, so you have triangle A, B, C, and this is let's say B, C. So this triangle and this one. These two triangles, so this one and this one. These two triangles would be equal because we have AP parallel to BC. This is first property. And second property is that triangle ABC and triangle PBC, right? They are on the same base and between the same patterns, right? So then what happens? Then there is this theorem which you have done in your ninth standard, and it says that the area of triangle ABC, that would be equal to area of triangle ABC. So whenever you have two triangles, they are on the same base and between the same parallel, then their area would be equal. So these are the two preliminary ideas that we will use in our next in this chapter. These are these points clear to you?
Yes.
Okay, so now let us understand about the first theorem. So theorem one, and I guess this is 6.1.
Can I note down the?
Yeah. So I will give you some time to note it down, right? Okay. This is the theorem 6.1. So, what does this theorem 6.1 say? And this is also called the basic proportionality theorem, or it is also called Thales theorem. Right. So, these are this is the name of this theorem, right? And what does it states? So let's say you have a triangle. You have three sides of the triangle, and then what do you do is that you draw a parallel to the third side. So you draw a parallel line PQ to the third side BC. So what you are doing, you are making parallel line PQ parallel to BC. So if this PQ is parallel to BC, then it will divide this AP line. This point P is dividing this AP line in two parts, this one and this one. And similarly, this Q point is dividing this AC in two parts, this one and this. So this P and this Q both will divide these two respective lines in a similar ratio. So it states that if this parallel, then AP by PB. So this is the ratio in which this P point divides this line. This would be equal to AQ by QC. So this is the theorem. I have not written in words, but you can write it in words. That if a line is drawn parallel to the third side, then the point where the parallel line is intersecting the first two sides. So the ratio with which these two points will be dividing these two sides would be equal. Then these ratio, that is the theorem 6.1. And yeah, we will prove this theorem because yeah, we will prove this theorem because it is there in the NCERT. So we will prove this. Okay, and one more preliminary that I will talk about. That yeah, so this one, please write it before this one, right? So the other preliminary is that the area of triangle. What is the area of the triangle?
Half into base.
Yeah, so I can choose any base. If I choose this, let's say, if I choose this base, then I have to draw the height from the remaining vertices. So I have to draw this height from here, right? So area of ABC, that would be half. If I choose base as BC, this is my base. So height would be AM, right? Not AC. Similarly, if I choose my base as AB, so if I choose this base, right, then I will take my height from the third vertices. What is the third vertices? What is the third one?
AC.
No, so I have chosen this base. E and B point I have chosen. So what is the remaining vertices of the triangle? Vertices is one
So
point.
AB is the base, and
So
you're asking.
C is the vertices, right? If I
Oh,
take,
you mean the vertex? Oh,
yeah, yeah,
yeah,
yeah.
it's C.
So that would be C. And you have to draw the perpendicular from here, right? So then this, let's say this is N. So if I choose my base as AB, then my height would be Cn, right? And if I choose my, so these are all the areas of this triangle. So if I choose my base as AC, so what is the remaining, what is it? Vertex, as you say. What is the remaining one?
B.
B. So we have to take the height from this point, right? So let's say this is M and O. So then my area of triangle would be AC into BO. So these are the things that we have to be very careful. And let's say if I take a triangle like this, right? If I take a triangle like this, and if I choose my base as BC, then can I make a right angle from here? Can I make a right angle from A? The vertex which is remaining, can I make a right angle from A?
Yeah.
I'm asking that on the side BC, can I drop a perpendicular line from A on BC?
You can draw a perpendicular from A
Yeah,
to.
we can draw, but can we draw or draw it on BC?
Oh, no.
So we have to extend this, right? So we have to extend this, and now we can draw. So this would be the height, then, right, for this triangle ABC. So area of ABC would be half BC into AM. So then AM would be this, right? So these are the crucial things which are important. So remembering this, now we will prove the basic proportionality theorem. So, but before we do that, you please note it down. So note these things down. So this is the property about E. Yeah, whenever you want me to scroll down, please set. Yeah, whenever you want me to scroll down.
You can scroll. Yeah.